Hello. In this problem, I'm going to in this video, I'm going to solve this problem about Alice and Bob pushing on a box. Okay, so the problem states that if Alice pushes on a box mass M, so this is Alice's force labeled A, the known force Fa, so Fa is a known value, it's the magnitude of Alice's force, in the southeast direction. So this is a compass. This is a top view here in the picture. This is a compass showing that north is that way, south is that way. Alice is pushing southeast. Meanwhile, Bob pushes on the box with an unknown force, aka a force with an unknown magnitude, because we know that he's pushing due north. As a result, the box overcomes friction and slides due east, so to the right, at a constant acceleration a box eastward. The first question is, what is Bob's force? Okay, what is the magnitude of Bob's force? Since we already know the direction, it's due north. Okay, so to solve this, I'm going to write sum of the forces equals ma, Newton's laws. And this problem I can do in a coordinate system north, south, east, west. Usually we do problems in coordinate systems x, y, but north, south, east, west works. So I'm going to say the sum of the forces in the east-west, I'll just call that east direction. It includes both east and west. West is just minus east. So the sum of forces in the east direction equals ma east, sum of the forces in the north direction, aka north and south, south is minus north, is ma north. Okay, so let's see here. Where should we start? Well, we're trying to find Bob's force. Bob's force is in the north direction, so we're probably going to need to use this second equation. So what are all the forces in the north direction? Well, we have we can break Alice's into two components. We can take it into a component like that and a component like that. I should actually probably clarify this by drawing a free body diagram. So this right here is not a free body diagram. It has the mass in it, and it has forces pointing in. So if I want to draw a free body diagram, I'm going to draw it here. I have Bob's force Bob pushing up there. I have force Alice pushing down there, and I have force of friction pushing back. Notice that the arrows come out of the dot, not into the dot. Okay, so if I want to break up Alice's force in the free body diagram instead of in the picture, I break it up like that. So that's force Alice in the south direction, I guess. Force Alice south, aka minus north, force Alice east, or east. Okay, let's see here. So back to what I was doing, I'm trying to find force Bob, the magnitude of force Bob. So I'm doing the sum of forces in the north direction equals ma in the north direction. So what are the sum of forces in the north direction? We have minus force Alice south. I'm going to assume I'm going to use by context force Alice south is a positive number, so I have to give it a minus to be minus north. North will be positive for me. Okay, so minus force Alice south plus force Bob, and it's just all of force Bob because he's directly north, is equal to ma north. Well, it's accelerating due east, so its acceleration in the north direction is 0. Okay, we can now break up force Alice south, or force Alice into force Alice south and force Alice east. Force Alice south will become just force Alice times, and then I need my angle in here. So let's remember our angle. So that is the angle there. So if I use opposite interior angles, that is 45 degrees right there. Because it's 45, it also happens to be 45 over here as well, but whatever. So I'll leave that as 45 degrees. So if I want force Alice south, that would be force Alice sine of 45 degrees is equal to force Bob. Plus force Bob equals 0. Plus force Bob equals 0. Solving for force Bob, I get force Bob is equal to force Alice sine of 45 degrees. I happen to know that sine of 45 because it's a common triangle is 1 over square root of 2. So this happens to be 1 over the square root of 2 force Alice. Either one of those two answers is right. We'll just highlight both. Whichever way you prefer. Okay, so that's how we solve for force, the magnitude of Bob's force. So I'm going to not put an arrow sign on it because these are just magnitudes. Force friction, force Bob, and force Alice are vectors. If we wrote them with the vector sign, if they write them without a vector sign, we're just going to assume that they're referred to the magnitude. So these are all magnitudes. Okay, so that's the first part of the problem. We can draw a line. For the second part of the problem, in terms of the given values, what is the frictional force while the box is accelerating? Okay, so now I'm going to use the other equation, the forced east equation. So sum of forces in the east direction equals ma in the east direction. So we have minus force friction minus force Alice cosine of 45 degrees. Plus force Alice cosine of 45 degrees because she's pushing in the positive east direction is equal to m. And then the a in the east direction, we're told, we go back up here, we're told that the acceleration in the a direction is in the east direction is a box, the subscript box to just denote what acceleration it is. Okay, so we know force Alice, we know the angle, we know m, we know a box. Those are all given values. We are just trying to solve for force friction. So force of friction is equal to, we move that to the other side, and the other thing to the other side, we get force Alice cosine of 45 degrees minus m a box. And that's all of it. We could also write it, I happen to know the cosine of 45 is also 1 over square root of 2, so you could alternatively write this as force of friction. The magnitude of the force of friction is 1 over the square root of 2 force Alice minus m a box. Okay. And that completes the solution to this problem.